Not that far away from the planet, in most cases, researchers have discovered a brand new planet called Proxima b recently. The most sharp image of Proxima b was captured at any time by the well-known James Webb Telescope. This planet is in the orbit of the star that is closest to our Sun, and an outstanding image provides a glimpse into a world beyond our immediate vicinity. This discovery has sparked questions and enthusiasm among researchers as a whole. What made this telescope capable of such an accomplishment? It opens a window to a location that might have living conditions suitable for life. Lastly, what does this brand new finding imply for our understanding of exoplanets and the vast extraterrestrial universe? Join us as we investigate the newly discovered image of Proxima, which will be observed by the strange planet discovered by James Webb's telescope. Proxima Centauri b is housed within the vastness of space around its star, 4.2 light-years away from Proxima Centauri, far from Earth. The initial glimpse of the highest quality image of Proxima b at this distance piqued our interest, inspiring questions regarding its similarity to our planet. Proxima b might be compared to Earth, which has abundant seas. Proxima's existence adds to the intrigue. Proxima Centauri's journey is not unique. It is in a circle with another significant Proxima planet, Proxima Centauri c. The same amount of energy is produced every century, much like how the Sun gets its energy from its star, causing researchers to be curious about whether or not this far-off planet could have water or sustain life. As we investigate the infinity of space, we encounter diverse exoplanets circling other stars within a bewildering 206 billion stars spread out across the universe, providing these opportunities. Exoplanets appear to be endless in some regions. These planets move around freely in space, comparable to huge migrants. Proxima Centauri b distinguishes itself as a unique puzzle in this extensive display of celestial bodies. Its year is surprisingly brief, only lasting 11.7 Earth days, and it revolves around its star significantly closer than Earth does to the Sun. As a result, one side of the planet is washed frequently in sunlight while the other remains in perpetual darkness, adding to the strange and possibly alien nature of Proxima b. Proxima b was first discovered using the radial velocity method, an extraordinary method for locating exoplanets. This method relies on observing a star's unsafe movements, caused by the gravitational pull of a planet circling it. As the planet orbits its star, it creates a tiny but visible movement that causes the star to change its orbit slightly, experts in space say. Spotting this change requires careful study of the spectral shifts of stars, a phenomenon known as the Doppler shift. With these minor adjustments in the star's range, the presence of Proxima b was confirmed. This demonstrated the effectiveness of the radial velocity method in discovering other worlds beyond our own planetary system. The discovery of Proxima b was a significant achievement because it confirmed the existence of an exoplanet within the habitable zone of the closest known star to our Sun. This finding sparked great interest among specialists and space researchers, who are eager to investigate the mysteries Proxima b may hold, as well as the significance of this discovery for our understanding of the universe and the possibility of life elsewhere. Proxima Centauri b is an incomparable marvel worth admiring. The image number 3 showcases Canopus, Regulus, and other celestial companions moving across Proxima Centauri, the closest star system similar to ours. As we investigate Canopus and Regulus, they combine in the night sky into a brilliant guide that unites everyone. These stars are in the large constellation, ranking third among the most brilliant, awe-inspiring us with their beauty at a maximum magnitude of 0.27. But it's only a modest Proxima that also has a fascinating secret, known as Alpha Centauri. This red dwarf belongs to the type class and is only 0.21 light-years away from its star. To put it into perspective, Alpha Centauri is numerous times farther away than the distance between the Sun and Earth. The name Proxima Centauri, which means nearest star in Latin, emphasizes its position as our closest neighbor in space. Robert, a Scottish cosmologist in 1915, demonstrated this divine discovery to the entire world. Despite its proximity, Proxima Centauri is difficult to see to the untrained eye, with an apparent size of 11.13. A great distance beyond the natural visibility limit of 6.5, it is an accomplishment in and of itself. Red dwarf stars like Proxima Centauri are powerful forces to be taken into account, efficiently generating energy through strong internal convection processes. This star is content to remain in its position as the primary star of the arrangement for another 4 trillion years, displaying enduring brilliance that has stood the test of time. However, the idea of being habitable is complicated. Proxima Centauri undergoes abrupt and unusual energy outbursts, and its lower mass hints at the existence of a habitable region with favorable conditions for life. The habitable zone of Proxima Centauri, where Proxima b resides, is significantly closer compared to our Sun's habitable zone. Despite appearances, Proxima b faces challenges, such as powerful ultraviolet radiation that is 10 times stronger than sunlight reaching Earth. Even for humans, radiation poses a danger, threatening the stability of necessary substances like nitrogen and oxygen. While Proxima b is located within the habitable zone of its star, the potential for life is far from certain. The extreme levels of radiation make it difficult to sustain life as we know it. Any potential life forms on Proxima b would be exposed to the brutality of space, significantly lowering the probability of life thriving as we understand it. Despite these challenges, the objective of uncovering Proxima b's secrets remains a driving force in space exploration. One of the instruments driving this exploration is the James Webb Space Telescope, launched at the end of 2021 following numerous delays. This cutting-edge telescope promises to make clear one of the most intriguing inquiries in cosmology: does Proxima b harbor life? The road to discovering the truth about Proxima b is not easy, but significant modifications have been made to the James Webb Space Telescope to ensure the accuracy of its images. As per a distinguished theoretical physicist at Harvard, Proxima b requires a sophisticated method for detecting life. The James Webb Space Telescope is capable of detecting the planet's faint light and supports researchers in searching for evidence of water or an environment conducive to life. The presence of water on Proxima b plays an important role in understanding the planet's potential to support life. Water is a fundamental element for life on Earth, and if discovered on Proxima b, it would greatly increase the chances of the planet being habitable or at least capable of facilitating some form of life. Proxima b, located within the habitable zone of its star, receives the same amount of energy from its star as Earth does from the Sun. However, Proxima b is confronted by intense stellar magnetic activity and radiation. Stability could be threatened by these factors, as well as any possible atmosphere. There is still liquid water present in some scientific models, though these models currently challenge our understanding. As researchers continue to probe the mysteries of Proxima b, the potential implications for our understanding of exoplanets and the conditions that might support life are vast. Each new discovery adds a layer of complexity to the questions we've been asking for centuries. Are we alone in the universe, and what does it mean for a planet to be truly habitable? Scientists are now turning to simulations, examining a variety of hypothetical scenarios to better understand the atmospheric and environmental conditions of Proxima b. While some models suggest the possibility of vast oceans beneath its surface, others hypothesize that water on Proxima b could be trapped in ice, or perhaps even hidden in subterranean reservoirs. The next step is to use advanced technology, like the James Webb Space Telescope, to gather more precise data about the planet's atmosphere, surface, and any potential signs of water. One of the key features that researchers are focusing on is the star's habitability zone, the region around a star where conditions might be just right for liquid water to exist on a planet's surface. However, the proximity of Proxima b to its red dwarf star presents both opportunities and challenges. The intense stellar flares and radiation from Proxima Centauri could make it difficult for life to survive on the planet's surface. Yet, in a twist of cosmic irony, these very same conditions may also create an environment where life could exist in ways we have yet to imagine. If Proxima b does harbor water, whether in liquid form or frozen, it would be a breakthrough for humanity's understanding of life beyond Earth. Water is, after all, the cornerstone of life as we know it. The discovery of water on Proxima b would not only raise the possibility of microbial life, but it could also offer a glimpse into the complex and diverse ways in which life might adapt and thrive in an environment vastly different from our own. Despite the challenges, scientists remain hopeful. As technology advances and our understanding of the universe deepens, the dream of uncovering the secrets of distant worlds like Proxima b remains within reach. With each new observation, we take one step closer to answering the age-old question of whether we are truly alone in the universe. The story of Proxima b is not just about a distant planet orbiting a faint red dwarf star, it's about our quest to explore the vast expanse of space, to understand the forces that shape the cosmos, and to ultimately answer one of the most profound questions humanity has ever posed: what is the nature of life beyond Earth? For now, the mystery of Proxima b remains unsolved. But as our tools and knowledge continue to evolve, so too does our understanding of what is possible in the infinite reaches of space. Whether Proxima b is a barren world, a frozen desert, or a thriving oasis, it serves as a reminder that our journey of discovery is just beginning, and the universe still holds countless wonders waiting to be uncovered. The challenge necessitates advanced telescope technology and particular atmospheric conditions, as our tools for observation continue to expand the mystery surrounding the atmosphere of Proxima b. It is anticipated that potential reserves of water will unfold, bringing us truly closer to understanding the nature of this enthralling exoplanet. However, its atmospheric presence alone does not guarantee habitability. Adam Turner, an astrophysicist at Princeton University, cautions against making assumptions based solely on the atmosphere. He warns that the planet might resemble Venus, with a thick atmosphere that chokes and extreme heat, rendering it unfit for human habitation. As of right now, we call it Proxima b. Beyond being merely a distant exoplanet, it emerges as an intriguing neighbor within our extensive backyard, enticing us with the possibility of its proximity creating conditions that could sustain life. Its Earth-like qualities make it a tempting target for upcoming space missions, igniting the interest of cosmologists, despite the fact that direct travel is beyond the scope of our current technological strengths. The position of Proxima b in relation to potential interstellar missions presents significant challenges. Reaching Proxima b would indeed necessitate a vast journey. Using current technology, such as spacecraft like Voyager 2, would take an incredible 73,000 years. However, the soul of human creativity and innovation drives space exploration, and in the future, possible solutions such as solar sails may transform space travel. These incredibly thin sails could push spacecraft at incredible speeds, conceivably reaching the Proxima Centauri system in 20 years, where Proxima resides. This technological leap makes the dream of traveling to an exoplanet like Earth within our lifetime tantalizingly possible. The discovery of Proxima b has rekindled human curiosity about the universe, giving us a fresh sense of hope and fascination. It serves as a testimony to our unwavering desire to venture into the unknown and learn something new about distant worlds and their existence beyond our own planet. The James Webb Space Telescope is a marvel in contemporary astronomy. Despite its limitations, it has a remarkable capacity for observing celestial bodies and illuminating the possibility of life on exoplanets like Proxima b. It faces challenges in determining how atmospheres are present and identifying conditions that are favorable to life. Proxima b's resemblance to Venus is a stark reminder that an atmosphere alone does not guarantee habitability, though the telescope's extraordinary capacity to detect the tiniest indications of life is promising. For instance, bright orbital mirrors could demonstrate Proxima b's potential, revealing its vast and mysterious universe. Exoplanets revolve around stars far beyond the farthest reaches of our solar system, showing an amazing variety in terms of their sizes and shapes. Some are massive gas giants like Saturn and Jupiter, while others have similarities to our own Earth. Gas giants are among the most awe-inspiring exoplanets, captivating cosmologists worldwide. Planets with structures similar to Jupiter and Saturn are often known as super-Jupiters because of their sheer size. These massive beings are so overwhelming that they render Jupiter, our solar system's largest planet, small by comparison. Gas giants orbiting close to their stars are exposed to temperatures capable of melting metals. Studying the characteristics of planets like these reveals a world on fire, characterized by violent storms and scorching heat. However, the exoplanet category is diverse, including exoplanets in the Neptune Sea, with sizes comparable to Neptune and Uranus. These Neptunes, both hot and smaller, have moved closer to their host stars than their larger relatives, and their encased atmospheres remain enigmatic. This challenges our comprehension of distant exoplanets. Scientists have made progress thanks to innovative technologies that enhance our understanding of the universe. As the field of exoplanet discovery continues to evolve, new techniques like the transit method have changed our ability to identify and investigate planets beyond our solar system. By studying the slight dimming of a star's light as a planet moves past it, astronomers have found thousands of exoplanets, many of which lie in the habitable zone of their stars where liquid water might thrive. These discoveries fuel our imagination and help address one of the most important scientific inquiries: are we the only ones in the universe? Alongside the discovery of exoplanets like Proxima b, astronomers are constantly fine-tuning their search for biosignatures and indicators that may indicate the existence of life on other worlds. By studying the environments of exoplanets, scientists can identify gases such as carbon, methane, and oxygen dioxide, which are linked to biological processes. The James Webb Space Telescope's potent infrared capacities are anticipated to play a critical role in this research, facilitating the detection of these gases even on distant planets a light year away. If researchers are able to confirm the presence of biomarkers in the atmosphere of an exoplanet, it would provide compelling evidence that life exists in other parts of the universe. However, the moment we turn our gaze to the stars, we must also look for signs of life in our own solar system. As we continue to explore the cosmos, the quest for signs of life doesn't stop at distant exoplanets like Proxima b. Our search extends beyond the stars to our very own solar system, where some scientists believe life might already exist, or may have existed in the past, in places we never expected. The icy moons of Jupiter and Saturn, such as Europa and Enceladus, are prime candidates for this kind of exploration. These moons are believed to harbor subsurface oceans beneath their frozen crusts, environments that could potentially support microbial life. Missions like NASA's Europa Clipper are designed to investigate these hidden oceans, searching for the conditions necessary for life to thrive, further expanding our understanding of the universe and its potential for supporting life. Closer to home, Mars remains a focal point for astrobiological research. With evidence of ancient rivers, lakes, and the presence of water in its past, the red planet is seen by many as the most likely candidate for discovering extraterrestrial life within our solar system. The discovery of methane spikes and organic molecules by rovers like Curiosity and Perseverance only fuels this speculation. The upcoming sample return mission, which aims to bring Martian soil back to Earth, promises to be one of the most significant steps in our journey to understand whether life ever existed on Mars, or if it still could today. While our gaze is fixed on distant exoplanets like Proxima b, we must not forget the potential for life in our own cosmic neighborhood. These investigations will continue to shape our understanding of life's existence beyond Earth. The boundaries of human knowledge are constantly being pushed forward by new discoveries, driven by the advancements in space exploration technologies, from more powerful telescopes to sophisticated landers and rovers. These efforts form the backbone of a future where humanity may not only find life elsewhere but may one day become an interplanetary species, venturing beyond our earthly origins to settle on distant worlds. As we look to the stars, one thing becomes clear: humanity's curiosity, perseverance, and desire to explore the unknown are what drive our search for life. Whether in the far reaches of the universe or within our own solar system, the quest continues, and with each new discovery, we move closer to answering one of the most profound questions of all: are we truly alone in the universe? The pursuit of this answer will define the next era of human exploration, and it is a journey that promises to inspire generations to come.